Welcome, everybody, to another episode of Today in Space. I'm your space science podcast host from the East Coast, Alex G. Orfanos, and we're back for another episode of People of Science, where we get to meet with people who are working in the industry. We get to talk about what got them into STEM, their passion, what they're doing for work, and it's a really cool insight in what it's actually like working in STEM. And really people that I think have a good passion about it. It's not just, another job that they're doing. So this week, we're honored to have Dr. Masha Petrova on, who is the CEO of Nullspace, and we'll talk about that. But first, Masha, welcome to the podcast.
Thanks, Alex. Pleasure to be here. I'm very excited.
Absolutely. I'm happy to speak with you today. We got a lot of stuff we're going to get into, but like we do on every episode of People of Science, let's talk about your STEM origin story. Where did it all begin and what made you decide to join this crazy journey of working in a STEM field?
Sure. So, my name is Masha Petrova. I am the CEO, co-founder of a company called Nullspace. So we develop electromagnetic simulation tool for electrical engineers, including electrical engineers working on all kinds of space applications. And then my background is I'm a recovering engineer. So my undergrad is in in mechanical engineering, and then my PhD is in aerospace engineering from UC San Diego. And I'm actually not a natural space person. I come from a long line of engineers, but I am personally very bad at math. I have dyslexia, so it's really hard for me to remember. Numbers are not typically a friend, which
Mm.
which is which is funny considering where I am now. And so I went into engineering because I was going to be an astronaut. So I grew up on Soviet Union science fiction. I'm originally from Soviet Union. I moved here when I was 12 to
Mm.
US because my dad was a chemist and he got a postdoc position here. So we moved with a family, and I grew up on Soviet Union science fiction, which was really good. Most of it is not translated, unfortunately, but
Mm.
uh, it's very unique and it's very different. And I read just piles and piles of books. I actually have some to show you here. And
I
most
love it.
of that science fiction was about space. And so I grew up visualizing myself living in all kinds of space worlds and space in the future.
Yeah.
And so naturally I assumed that that's what life is just going to be like. And
Hmm.
so
Right.
figured I needed to become an engineer. And so I kind of brute forced my way through undergrad engineering. And then once I got into grad school, I luckily once you get to higher levels of math, it becomes much more conceptual. There's a lot less numbers,
Right.
a lot more symbols. And
Mm.
so it became much more interesting and more natural for me because it's much more visual. And so luckily I was able to push through that initial bulk of math to get to the higher levels of engineering, and then it became fun.
That's
And
awesome.
then I was a real engineer for about a year, and then decided that I'm way too extroverted to
So,
kind of
so
stay an engineer.
you have to describe what you mean by as a real engineer. What did that mean to you?
So I was a, PhD level researcher engineering in a small startup developing simulation software for chemically reactive flows out of all things. So things
Mm.
that are flowing and reacting, like think about
Oh,
gasoline in a car or all
yeah.
kinds of fuels in a space engine. And someone has to develop those fuels and simulate them. And so that's what I did as a quote unquote real engineer.
And so what was it like what was the moment that you just decided, like, was there a bunch of things? You just realized like this wasn't just what you wanted to do, what you went to school for, or what you went down this path for?
Yeah, and to be clear, I still love the engineering side of things. I
Mm.
like solving hard problems. Um,
Mm.
but I just kept talking to people too much, so I was talking way too much and not spending enough time in front of the computer. And
Uh,
so what happened was the salespeople were like, "Ooh, this one can explain things to us. Let's start bringing her to our customer meetings. Let's start
mm.
asking her questions." And I loved talking to them. And so I became sort of a liaison between the developers and the engineers
Mm.
and sales and marketing people. And then I
Oh, yeah.
realized that, ooh, in marketing, you can deal with things like colors and how to make things pretty. And
Mm.
I love that aspect. And so I went into marketing and led marketing teams in hard engineering type of companies ever since
Mhm.
then.
Wow, that's super interesting. I find myself in that I work as an engineer, but as really helping the customer who has the device on the other end. It's not working or it's not doing what they want. I help them figure that out. And I also got picked up by a sales team because
There you
I
go.
my journey was more like I couldn't uh it was a weird time where in aerospace there were not a lot of jobs. You were either overqualified or underqualified. It's a different world today, but I there were opportunities in that bridge between the technical and the I guess people side of things. And so that's very cool. How was that first transition? Did it feel like you were fish in water, or were there things you had to learn along the way?
Oh yeah, I had to learn a lot of things. So that transition was pretty crazy. I had a pretty crazy boss who was
Mm,
VP of sales at a time, who did a lot more talking about how great he was than actually selling anything. Actually, I don't know if he
mm,
ever closed a sale at that company. Uh, but he because he was not an engineer, he struggled in front of customers, and I didn't.
mm.
And I was really young and I didn't, I am a Russian engineer. I'm very like straightforward. I
Yeah.
say what I think a lot of times. I learned not to since then, but especially back in the day. And so there's a few times that I made him feel uncomfortable in front of
Mm,
customers because he just felt like an idiot. And so he
yeah.
would try to teach me things to kind of at least
Mm,
feel, I think, like he was competent in doing his job. And so one of the things he said to me one time, he would say all kinds of random things, but one time he came into my office and he's like, Masha, this was my first year as a sales engineer, right?
mm,
I'm the token sales engineer in the company. All salespeople come to me with
yeah.
questions and
Yeah.
customer problems. All engineers come to me when they're irritated with sales and are trying to understand what sales is doing. And so he comes to me and he goes, have you ever looked at your face in the mirror when you're talking to people? And I said, I'm a PhD engineer. Like,
Right.
no, I don't typically just stare at myself in the mirror when I'm
Yeah.
talking to people. And he goes, because you kind of look like a murderer. Like you kind of look really scary.
Mm,
And so because when I'm thinking
yeah.
about, I don't know, PhD level engineering problems, you concentrate and you tend to, I don't know, I tend to zone out and
Totally.
concentrate. And I guess I look
Yeah.
like a murderer. And so he's like, here's what you got to do. Go to the corner of go to that CVS on the corner and buy a
Mm,
little mirror and just put it in your desk. This was before Zoom
mm,
and looking yourself in the camera. Put it in your desk and just look at your face when you're talking to people every
yeah.
once in a while. And even though I think he totally meant it as a demeaning comment, like
Mm,
I don't think looking back, he meant it as like, oh, I really want you to grow and I'm trying to prop you up. I think he
right.
was really trying to push me down. However, it turned out to be a very useful, a useful hint to be
Mm,
more paying attention to your body language when you talk to people.
yeah.
So there you go. There's a story for you.
I love that. It really is. I cut my teeth in that area. I worked at Apple for a little while. I was a Genius
Oh,
Bar. I would
wow.
help people with problems, and then I would take the iPhones out back and work on them. And that was one of my favorite jobs, but it taught me how to be a better engineer, communicating stuff because there's all that short time. People come, their life is over when they come with you with a technical
Yes.
problem, and you have to
Yes.
bring them through that whole process and also set the right expectations from the very beginning, so that way they leave
Yes.
happy. And that I think has been a huge tool for me. It's been a great tool for this podcast tool, just to learn how to talk with people and really get to the point. And
But that's
not
amazing.
yeah. So I think that cross section, there's a lot more people that would fit in that area or that started in engineering and then that opportunity to cross over doesn't exist at that time and then they leave the field. So I'm always
Yeah.
interested. To hear about stories like this. So I'm sorry, we were talking about that time. So take me further. How did it develop from there?
So at that point, I tried to start my own company because I was always fascinated. Back in the day, I
Mm.
read the book called 4 Hour Workweek by Tim Ferriss.
Yes.
Are you
Amazing book.
familiar? Well,
Yes.
right. When it just came out, like
Oh
no one
wow.
knew what it was, like he was just getting started. And I was very inspired by that book. Funny enough, I read some of his other stuff that came out, was never did anything like that for me again. It
Mm,
was only that first one. And
yeah.
so I found out about this place called Silicon Valley, never heard of it before, and I
Mm,
thought like, what is this? This is fascinating, and just became completely fascinated by the startup world and Bay Area and Silicon Valley and that whole story, um, and decided I wanted to be CEO of a tech startup, and one had that dream for, I don't know, good 15 years until I became one. So
it's
that's the
incredible.
story. Yeah, so then I was head of marketing, a VP of brand marketing, chief
Mm,
marketing officer, VP of global marketing for a variety of engineering software companies,
mm,
that all our customers were the same. They were aerospace, they were defense, automotive,
mm,
communications, large companies that do a lot of R&D and need engineering tools. And so I
mm,
worked in, I don't know, I think a probably total of 8 or 9 companies that developed various software tools for those types of engineers.
mm.
A bunch of those were startups. Some were complete dumpster fire startups, like out of a Silicon Valley TV show,
Yep.
which was fun. Some were big public companies.
Mm,
Um, I've been through multiple acquisitions, overseeing acquisitions as a head of marketing and kind of assembling those companies together,
yeah.
and being on the acquired side and being acquired and overseeing the acquisition from that end. So that's been very interesting.
That must be a journey. That's I've been a part of that in tech, and it's a ride. Um,
Yeah,
and you've
definitely
done it
right.
how many times now?
I think I've been through, as head of marketing, I've probably been through 5 acquisitions,
Wow.
like on one or the other side, or
Oh
more at
man.
this point.
Could
Yeah.
you break down to folks, because I didn't understand this until I got into tech and the startup world. How how would you explain that to somebody who isn't in the industry and what that process is like?
What the acquisition looks like.
Yeah.
Yeah, so in the world of startups and large public companies, bigger companies tend to sometimes buy smaller companies. And when you're just an employee, right? You're an engineer out of a group of engineers. So you kind of like, that doesn't touch you until you start to complain about like, oh, like the coffee machine is gone, and oh, like all our branding is now purple instead of green, and it's annoying and I have to redo my PowerPoints,
Right.
things like that. If you're in the executive level, so you're in a C-suite, you're overseeing, let's say, a department, whether it's R&D department or sales department or marketing department, you have to either integrate into the larger company, and that's interesting,
Mm,
or you have to integrate the smaller companies. And a lot of times the small company that got bought and the large company that bought that company have different interests.
right.
And what's been funny is, and I've been in this shoes as well, is before I actually was on the acquiring side, I never understood, I thought there's so many things that were just stupid that were
Mm,
happening during the acquisition, right? And you're
yeah.
like, why are they changing all of this stuff? And why are they not
Things are
changing
just
this? And why are
changing. You
not
don't know why.
right?
Yeah.
And why are they not giving us more resources? And it's like, well, the acquiring company is much bigger. They
Mm,
bought you, you know.
right.
In Russia, there's a saying called that says, I'll try to translate it, but he who he who pays orders the music. Like when you like pay for
Yeah.
the
Yeah.
machine, the
The
music machine
jukebox.
or whatever,
Yeah.
the jukebox, exactly right. So same thing here, is you kind of
Mm,
understand, well, whoever's got the money is whose interests
true.
are going to come first. And
Yeah.
yeah.
It's I remember reading um Ashley Vance's book on Elon Musk. And that was right before I got into tech, and it was a really valuable book to understand uh what to expect from tech. I didn't know anything about acquisitions or working for a small company or working in tech. I didn't know any of that, but I remember that book really has been foundational over the years, and has given me a lot of good expectations going in on on what could happen, because startup life
Hmm.
is not for everybody, like you're saying.
Yes.
Like I think someone who actually excels in an engineering role, a classic engineering role, is not going to enjoy the startup life. because it's crazy in a
Yeah,
lot of
you
ways.
Yeah, you build your own system that you essentially have to cook in, right? You come in
Yeah.
to a larger company, the system is already built for you. You could be
Hmm.
creative or you could build things, but it's in your own narrow space. And a
Right.
lot of times people are very comfortable with that, and that's what they want to do. It provides a lot of security.
Yeah.
It allows you to be creative or free in a lot of different, in the ways that are in a startup world, you can. I am not free in a lot of ways when
Right.
I'm building my own company because all of my brain power and energy is going towards
There are things that
building the
need to
system
happen. Yeah.
exactly that I'm going to be living in. But for me, freedom is such a big value to me.
Mm.
And autonomy is such a huge value that I'm willing to
Mm.
take all kinds of pain and discomfort for autonomy that I get in a
Mm.
startup. So, and I actually, when I was in public companies, the longest that I've been in a public company was at a company called Altium. So they just
Mm.
got sold for $6 billion. But they developed software for PCB design for
Mm.
electrical engineers.
Yeah.
And so I was VP of brand marketing there for 2 years. And towards the second year, I had a great team. I was very nice people, but I was like clawing the walls. I felt like a trapped lion or something, like clawing at a cage
Yeah.
because I forced all the boundaries I could. I built everything I could, but it was still structure of imposed
Mm.
structure of something else. And so I left to go startup.
Yeah. Yeah. It's so interesting. So for I've been on a real kick about creativity and how it comes from a different place than say logic and the things that like engineering comes from. Although I don't think they're separate. Um, w- what have you seen? Because you've kind of jumped into a creative role and then, out into running, a company, leading a company. Um, is there creativity in each of those jumps that you've been in? Um, and is that part of the freedom and the stuff that you're looking for?
Yeah, absolutely.
Mm.
Every time I came into a new company, I would always have this. I joke, it's like a honeymoon period of 6 months because during that 6 months, I typically would build a team
Mm.
because most of the times when I would come in, if I was a startup, there was no team. So I'd start from scratch as head of marketing. If I was a public company, I came into Altium as VP of brand. There was no team.
Mm.
So we built a whole program around customer success stories that didn't exist.
Mm.
I built the entire PR department that didn't exist. We built a really cool video series about highlighting various customers of Altium. So all of
Mm.
that had to be built from scratch. So you're building a team, you're hiring people, you're coming up with projects, you're coming up which tools are we going to use to manage all these projects and things
Right.
like that. And then, I got so good at it because I've done it so many times that I would build a marketing department within, I don't know, 6 to 9 months.
Mm.
And after that, it was like, okay, now you've built everything you could. You can now iterate and perfect
Mm.
things and make things better, but you're not building from scratch. And
Right.
that's what I would get restless typically.
But classic engineer, you're building a system and then kind of letting it run.
Yeah, so my what I figured out is that I love building systems. That's the weird
Mm.
part. If not being a math
Mm.
person and typically not being detail oriented, in some areas I'm hyper detail oriented.
Right.
In some areas I'm hyper focused on systems. And
Mm.
so what I figured out for me, because I'm an extrovert, but yet I'm also an engineer, I like building out of people. And so building
Yes.
systems out of people, as creepy as that
Ah,
sounds, but it's really not that creepy.
no, I get it. Yeah, I'm sure that could be creepy, but it makes
Yeah,
sense to me.
it makes me think of like the Matrix, remember? Like when they were all
Yes.
in that slimy things.
And they're
So
they're
not like that.
unplugging. Yeah.
That's right. Not like that. But building out of people,
Right.
and building something greater that the sum of the parts is greater than each individual
Right.
could contribute is
Mm.
what's exciting to me. And that's where I found my niche.
Mm.
I still build systems. I still figure out where the parts fit, but it's people. So it's very people oriented. I still get
Mm.
to be my extroverted self.
That's so cool. It's interesting. I feel similar to 3D printers in that way.
Okay.
I have a lab in my basement here, and then that's, getting one of those and building a kit online is what made me take the jump into tech and the 3D printing world. So
Well,
like
that's
that
awesome.
skill has just carry through. But for me, the printer, they each have their own unique abilities. I can tune them certain different ways. But, I am weird in that I work in my day job working in 3D printing systems, and then I go home and work on my own 3D printers. But for me, like that stack is just pure creativity and love, and then I would do it all day long, and people at
That's
work
so
look at me
cool.
crazy, but I love
Oh, but that's
it.
awesome. See, you found your niche, right? You
Yeah.
probably are very good with your hands. You love
Yes.
learning and you learn through experimentation with your hands.
Mm-hmm.
And that's not everybody. Some
No.
engineers that are more in the numerical side don't, right? And so
Mm.
you found that combination of what works for you, which is so great.
Thank you. Yeah, it is. I mean, this podcast has been a journey of finding all of that. So it's so cool to be able to talk with people like yourself. That, it's different. You found your different thing, but I love hearing about that journey. That's what this whole segment is about.
That's
Um,
awesome.
but let's dive into null space. How did it start, and let's tell the folks like what it is that null space is doing.
Wait, actually, before that, if you don't
Yeah,
mind, can I
please,
show you?
please.
Can I show you my
Oh,
props? Because I
I
prepared.
I would love to see them. I was going to save them for afterwards because I want to make sure we talk about null space, but let's do it now.
Okay, just really quick. So this is
Yeah.
some of the books. So I love reading, and this is some of the books that I either brought with me from Soviet Union or I ordered here. So they look pretty
Mm,
ragged. But this is some of the Russian science fiction. So these two authors are called Brothers Strugatsky, and so they write a
the
lot
art on
of
that is amazing.
isn't that cool? So I mean it's
Yeah,
old, it's old.
I love
I
it
read
though.
it a
It's
lot.
in good condition for how old it must be.
I think this one is 2004, so this is not
Oh,
that
okay.
old. But this one is actually a
Wow.
publication that was published by it's called Chemistry and Life. So it was actually a well-known magazine back in Soviet Union, read by a lot of
Hmm.
scientists. My dad read it, but they published a lot of really good, like scientific science fiction that scientists would actually read.
Oh, wow.
So this book is called A Village on the Edge of a Galaxy. And that's
Wow.
by another Russian science fiction author. I think this one was written in the 80s, so it's an 80s book. And then this
Wow.
one uh, is also a collection of science fiction stories, but you can see that's Stalin and Hitler, I believe, as far as the masks and their aliens, because there's some sort of a convoluted
Wow.
story of aliens and history, and that's right, real world, tyrants that live on this earth. So
Weird, and that they're like the aliens to Earth.
I know it's
Wow.
weird. Yeah.
Wow. That is weird,
Yeah.
but wow, that is incredibly, incredibly Russian. I love
It's very Russian. Wait,
that.
hold on. So last thing I'm
Yeah,
going to
let's
show you.
go through the wall.
So my through the wall. So my grand this is just generic your
Okay.
space shuttle photos from, your NASA center that you could buy in the NASA Visitor Center. But I do have something here. So my grandfather was an aerospace engineer, and he was one of the main leaders in charge of the space race. So
Mm.
he was one of the engineers developing the orbit for Sputnik, the
Oh,
first
wow.
satellite in space. Yeah, so he gave me some paraphernalia that's sitting here on my wall. Let me see if I can I can do this. Um, so right here is photographs from I believe this is Soyuz 24 and Salyut 5. This is from year 77. So this is a picture of some of the Russian astronauts. They're signed. So they signed it for my grandfather from that mission from 1977. Um, some of the Russian cosmonauts. And then this is a letter from my grandfather that just basically tells you what these two things are. This is a medal that he received for his work in Soviet Union aerospace, uh, space race.
Mm-hmm.
And then this is actually a piece of heat protectant cover
Mm.
um, for like a missile that was or not a missile, a spacecraft that was returning from uh Salyut was the space station, I think, in 1974. So that's like a heat protectant cover that chipped off that is melted on the outside
Wow.
uh from the 70s. So that's kind of exciting.
That's incredible. That's some history right there.
Yeah. Yeah, so I figured, your viewers might be interested.
I don't think I'll be able to see something like that cool like that that's from that era. That's incredibly cool. Thank you for showing me that.
From the other side of the Iron Curtain,
Yes. Yes, the fact that we're seeing it is incredible.
Yeah, it's
Wow.
kind of exciting.
That's so cool that you have that connection back to, I mean, as far as Sputnik. That's very, very cool. So
Yeah, thank
tell me
you.
about Null Space.
Nullspace. So that brings us to Nullspace. So Nullspace is we're about a year and a half old at this point as far as the company.
Mm,
The technology itself has been around for about 10 years. So we spun out of a defense contractor in Huntsville, Alabama. They develop very sophisticated radio frequency technologies
mm,
for all kinds of defense applications. And the engineers there wanted a tool that was faster than the current simulation tools. So when you build anything or you develop anything, you know this, develop anything as an engineer, you gotta test the thing that you've designed. The
yeah.
easiest way to test the thing that you designed is in a computer
Mm,
simulation. So there's all kinds of programs. Actually, there's not that many, but there's some programs that allow you to simulate real physics inside of a
mm,
computer. And so Nullspace is one of those tools. It simulates electromagnetics in your computer so that as
mm.
you're designing your RF device, like antenna, a radar, anything else that has RF signal in it, you can simulate it in Nullspace and
Mm,
make sure it works properly. And so the reason why we're different is we're much faster than the commercial tools out there because
mm.
it actually turns out that it's pretty hard to develop an engineering simulation software. It's not like an app, it's not Facebook,
Right.
it's not Instacart. You can't just take a few developers and put something together in a few months.
Yeah.
You know, it requires deep engineering understanding
Mm.
and coding and then testing the software against experimental data to make sure it's
Right.
simulating reality properly.
Right. Right. I
Right?
mean, there's so much there, and I think I just got the wordplay on the name. Is that a linear algebra
Yeah,
reference?
you got it. You got it. And Nullspace
Uh,
actually refers to a matrix that's got the everything is zeros except on the diagonal you've got actual numbers.
oh, I love
That
that.
are not zeros, non-zero values. Yeah. So
So let's talk about linear algebra because that was torture
okay.
for me. Talking about numbers. I mean, but it makes when you realize what you're trying to do, and this is like the problem of, um, correct me if I'm wrong, but traveling in three-dimensional space without knowing where you are in three-dimensional space, and then it with the software being able to interpret physics in three-dimensional space through mathematics.
Yeah, so okay, to be clear, I am not the inventor of the
Right.
tool for sure.
Right.
I've got much smarter. So my co-founders are brilliant. They are also co-founders of the defense company that spun out this technology. They're both PhD electromagneticists
Mm.
and very smart, and this is their brainchild.
Oh, that's
Um,
incredible.
yes, I'm just here to. I made the pretty logo, you know.
And to communicate it though, because I'm sure to be that genius, this is not necessarily what they would want to be doing right now. Or, you know, you would be able to tell the message, I think, much better, just as they would be able to tell you what's happening in three-dimensional space than either of us would be able to.
Yes, they
Yeah,
hired me to do the dirty work of
that's
communicating and marketing. That's right.
there's enough food for all of us. Yeah.
Yeah.
Well, that's very cool. That was one of the I think one of the hardest classes I've ever taken, although I found it completely fascinating.
So what kind of engineer are you, Alex?
Aerospace, and
You're
I had a
aerospace.
yes, and a concentration in astronautics,
Ah,
mm.
awesome.
And a jazz
Okay.
performance minor. So a
Mm,
very interesting degree.
I have a religious studies minor. So
Oh, interesting.
there you go.
Was that all religious studies?
My minor was religious studies, yeah.
Oh, cool.
So it was
Very cool.
it was all of it.
Nice.
Yeah. But I'm not religious, which is funny enough. That's probably why I want to study it.
Hey, now you know. Oh,
That's
that's
right.
very cool.
But yeah, if you think about it, you know, what's interesting is my background is not in electrical engineering or electromagnetics.
Mm,
My first foray into that space was Altium, which is the
mm,
PCB design software company. And that's where I started kind of my customers became electrical engineers.
mm,
But really, that's not my background. You know, I'm much more on the mechanical side, fluid dynamic
right.
side of things.
Mm,
And so electromagnetics is its own beast. As, you know, people call it black magic because you can't see
mhm.
it. I was
Yeah.
actually I was getting a tour of the parent company's lab. They have this
Mm,
amazing lab and sort of demo space where they have a plasma reactor and all kinds of crazy like antenna devices and things like that. Um, and they were describing to me like a test that the engineers were doing. It was really sophisticated antenna that cost, I don't know, millions of dollars to develop and design for the Department of Defense.
Mm.
And, they were all excited they were going to do testing, and they set it up, and the testing is just these two black boxes just, sitting there, and a bunch of engineers measuring stuff. And that's it. That's the exciting, millions
Yeah.
of dollars test.
They are loving every moment of it.
That's
Yeah.
right. So, but if we think about it, RF technologies and everything,
Mm.
everything has become a computer in the last, I don't know, what would
Yeah.
you say, 20, 30 years? Your satellites
Yeah.
are computers. Cars became computers. Everything's
Right.
connected with Wi-Fi, Bluetooth, antennas,
Hmm.
LiDAR, all kinds of stuff that's floating through the air, and we're not even aware that it's there.
Yeah.
Right? I'm talking to you with these
Wi-Fi.
Bluetooth headsets,
Yeah.
we're on the internet, we're talking to each other because of exactly the
Exactly.
Wi-Fi.
Yeah.
And all of that is RF, and something has to make it work. And that's RF devices that all need to be designed and tested and
Right.
simulated with Nullspace.
That's incredible. I don't think most people even realize that. I mean, I didn't fully realize
I
that.
didn't
Yeah.
either until I started working here. That's right. That's right. And that's what's interesting, so now we're at a startup. We're actually raising venture capital at this point. We
Mm,
are funded by our parent company, but we're raising
mm,
VC money. So I don't know if you have a lot of startups here, but in space, there is a lot of space startups that are starting out. I mean, SpaceX
hmm.
started out as a startup at one point.
True. Hmm.
And so this journey of raising venture capital is familiar to a lot of people.
Yeah.
But, trying to explain to finance people about what is RF,
Right.
if they have no idea, right? Like, and
Yeah.
again, it's not something you hold in your hands. It's not
Mm,
something that you see.
yeah.
And then on top of it, trying to explain to them what is software that simulates that RF. It's
Hmm.
like another invisible thing that you don't see, but requires a lot of money and time and engineering expertise to develop.
Yeah.
That's been a journey for sure.
Yeah, absolutely. And I think it's tough. I mean, having worked in engineering now, I can definitely say like being able to simulate something 85% of the way is I kind of do that with 3D printing, right? I don't 3D print the final product like we printed, this James Webb Space Telescope and a kind of multicolor filament because I didn't
Cool.
have multiple colors.
Nice.
But now I'm getting closer to what will be the final thing, and this is three colors here.
Oh, fun. That is so cool. I love
Thank
it.
you. Thank you. So like I could never have told you that I would have needed six different softwares to get there. But I know that because I'm deep into this. Engineers know that a simulation is going to bring you closer to this final thing than you would
Hmm.
before. And it's you're right. I don't think it's a very easy thing to explain until you have literal examples in front of you and you can explain like I'm sure you've done through marketing, explain the story of, here's the problem, here's what we did to solve
Hmm.
it, and here's the ROI and all the value that came from it.
Exactly.
Hmm.
Wait, I gotta tell you, so I have a special
Please.
connection to 3D printing as well. So one of the startups that I left a company called MSC Software, another
Hmm.
large public company with historical roots in engineering simulation space. And I went to a startup, and it was simulation software for 3D printing, specifically for
Oh
additive
shoot.
manufacturing, metal additive manufacturing. And
Ah.
the idea was to simulate how the part will print. So this was metal specifically,
Hmm.
how the part will print before it prints, so that you can calibrate your 3D printer to make sure that to account for any deformations or things like that. And so I was CMO of that company for exactly a month before it got bought up by another large company. So that was one of those acquisition stories. But for a long time, I knew every player in additive manufacturing space, all the software tools in that space, and uh, yeah, it was fun. It was during that
Hmm.
like the heyday of 3D printing. I don't know, maybe 7 years ago or so, or
Oh yeah.
5 years ago.
Yeah, and I was lucky enough to just have been in the Boston area when the hub of 3D printing in the world was happening around me. So, yeah, it's interesting. I feel like the post-COVID 3D printing at home and being able to jump supply chain has really grown a lot of interest in people having 3D printers at their home, like the start of that boom the last time. It's a very interesting time for that.
Yeah.
Um, but it's interesting. I mean, I have worked as an application engineer, which when I would tell people that, most people would think I was an engineer for a software, but really it was the application of 3D printing. What is this part? How will this part make save our company money? How will this part, sell a printer? But the
Mm-hmm.
irony was that I needed to know six or seven different softwares at any given time to be really good at my job. One to design, one to check for problems in design, one to slice, one to so it's so much it's so interesting how many programs I know at one time, and luckily all uh the controls are mostly the same, so I only slip up every once in a while.
Wow, that's impressive. Good for
Thanks.
you.
Thanks. I mean, it's job security, so um
Engineering software is the future, I tell you,
yeah,
that's where everything's going. So good for you.
definitely. Thanks. And I mean, it sounds like Nullspace is really helping with a lot of those areas and in a really unique like quad or multiple of industries like academia, defense, aerospace, and commercial. I don't feel like you work in all of those most of the time with just one product.
Yeah.
Is there any kind of challenge with that? Are each of the softwares like their own independent entity or the end consumer versions of them, or have you found a way to kind of allow them to help with each other and they're just a different facet?
Mm. Yeah, so we have two product lines. One
Mm,
is for electromagnetics and one is for electrostatics. So electrostatic software
mm,
is actually unique. We don't have any competitors to that product. And that's been designed specifically for quantum computing industry. So I
mm,
know we wanted to touch on quantum computers.
yeah.
So there is all kinds of different types of quantum computer technologies out there. One of those technologies is called ion traps.
Mm,
So that using ion traps for the to build the quantum computer. So there's
mm,
a very large company that just raised over $1 billion, spun out of a large defense company that uses our product,
mm,
and so that product called Nullspace ES stands for electrostatics is for
mm,
quantum computing industry. And then our Nullspace EM electromagnetics product is for any industry that has large problems where current commercial software cannot handle those problems, like
mm.
phased array, for example. So there's phased array that are used for um, what's the Elon Musk's internet with the satellites?
Oh, Starlink.
Link. Starlink, yes, thank
Mm.
you. So Starlink uses a lot of these phased arrays. So that's a new
Ah,
type of technology. And these things can be it's called electrically large,
mm,
meaning you can have a small antenna, but it is a very electrically large problem. And that's where null
mm,
space comes
mm.
in, and we're much faster and we're able to handle and digest, process that problem and give you the result much faster than the current the incumbents, the current
Yeah.
commercially available tools. And so whether it's defense, antennas built for defense applications, antennas for aerospace applications, or radar type of applications
Mm,
for communications, again, defense, aerospace, automotive, doesn't matter.
mm.
The electromagnetic problem is still the same. The application of
Right.
where antenna might be sitting is different, but it's
Mm,
still the same. Uh, the place where there hasn't been much maybe simulation is wearables and consumer electronics,
mm.
because so far it's been so cheap to just prototype and test that
Right.
historically there's not
Mm,
been a lot of simulation, but I think we'll see that changing as
mm.
the software becomes faster and more consumable and not as crazy as expensive as it was before.
Yeah, that's a really interesting cross section where I've learned working for a company that's making a device, how expensive making the first device is. can be. And
Mm-hmm.
that's where, even though, I think simulation software can look expensive from the outside, if you know how expensive it can get by actually building the real thing, it's really becomes a big saver.
Yeah, simulation could be a lot more cost effective for
Yeah.
sure.
Now, is there how about for usability? I remember, now this is, I'm dating myself, but when I was in college in 2008 to 2012, um there it was difficult to use simulation software. You really, and I say difficult because you just had to set up uh every aspect of the reality that you're trying to um simulate. Is it with, electromagnetic with that being the focus, does that simplify the user interface, or is there a lot of training that goes into using the software as well?
Yeah, so not yet. So currently, because it is so difficult to design the solver, the kernel itself, we call it the
Right.
kernel, right? The solver that actually takes electromagnetic Maxwell's equations, puts them into linear algebra sort of terms, and then we code the linear algebra in computer code, and that's your solver.
Yes.
That is very difficult and it takes years to do. Then you have to
Mm,
test it on experimental data to make sure that you're simulating the
right.
right thing. So that was such a bulk of the work, and that was what's been done for the last decade for Nullspace's software
Wow.
tools, and that's what we focused on. So we focus on the hardest part, and that's creating the solver. So
Yeah.
the usability, to be completely honest, is not there. This is a tool that's made for PhD level
Mm,
electrical engineers that are comfortable with Python, that are comfortable with scripting in Python,
right.
and so on, that understand the simulation process. And that's a very small pool of people. So
Mm-hmm.
what is on our roadmap, and why we're trying to raise funding, is to
Mm,
focus exactly on that, to focus on usability, to democratize the software for a bachelor's degree electrical engineer who just
right.
quickly wants to simulate something. And then for
Mm,
that, the usability has to be very important. Customer experience, user experience has to be very important. And that's the next focus of
cool.
the of development.
Yeah, and I think you guys took the right path. I mean, we're seeing, and this is my opinion based on you know hours of research, but I'm certainly no expert in AI. But what we're seeing with the application, the AI rubber hitting the road, we're seeing weird subtleties I don't think any of us would have realized, like AI giving us an answer even though it doesn't know that that answer is correct, because it was asked to give an answer. And in some cases, you know, not it depends on the person who has written the code and maybe the approach that they took to it. Um,
Mm,
I find it really interesting, when we think about all of 3D space kind of being shown back to us, right? With a lot of stuff that's going with AI and VR, and the amount of
mm.
processing and power that's going to be needed to convert all that stuff. Um, I'm super interested to see where a lot of this goes, and I think what you guys focused on it, making sure that it's actually explaining reality well. I think the user interface aspect is is not going to be an easy problem, but it's going to be, I think,
It's much
less
easier.
difficult. Yeah.
Oh,
Yeah.
absolutely. It's much easier for sure. And and
Hmm.
to be fair, that's the reason why the competitor tools out there, their solver technology has been around for 30, 40 years unchanged. And
Wow.
what those companies have been focused on just perfecting the user interface and
Mm,
tweaking things to make the user interface much better. And
mm,
so that's our biggest challenge, really. It's not our software is better, it's faster, it's more
mm,
accurate in most cases. But because it's not as user friendly as these commercial companies that spend millions of dollars developing the user interface, we really have to find those experts who understand the value in a faster, more powerful solver. And
mm.
so that's our early adopters.
Yep.
And that's the customers that we have right now that appreciate the power and the speed of the
Mm,
tool. And then the next level is to start to really build out that user interface. And
Yeah.
it's interesting. You mentioned AI and the chip proliferation right now and that whole craze. In
Mm,
the recent, I don't know, 2, 3 months, um, the two public companies that I worked for, which is a company called Ansys, which you
mm.
probably heard of as an engineer.
As an
Most,
engineer,
most,
yeah.
yeah,
Outside of
most
it, I wouldn't
engineers.
have though. Yeah.
Right, right, exactly. No one, it's like a company no one's heard of except engineers, right? Engineers
Right.
know it really well, and
Everyone knows.
everybody
Yeah.
else has no idea what the heck it is. So it just got acquired by
Mm.
Synopsys for a pretty crazy multiple of 16 times the revenue, which in investment
Wow.
world is a
That's
crazy number,
yeah.
especially for
The
a
golden goose.
slow, right, a slow,
Yeah.
non-sexy company that, like, again, no one's ever heard of if you're not an engineer.
Right.
And then Altium just got acquired
Mm.
for 6 billion for a 30 times multiple of revenue, which is again an investor. I mean, to me as an engineer, it's like, okay, whatever. Like, yeah,
Right.
it's a really big number. To an investor, 30 times revenue multiple is humongous and crazy
Yeah.
and doesn't happen in engineering software space. And
Mm.
so, and today there was another acquisition announcement by Cadence Design Systems,
Mm.
which if you're an electrical engineer, you've heard of Cadence. They've
Mm.
developed a tool that was competitor to Altium.
Uh,
They just acquired another simulation company. Not as crazy of an exit. It was, only for $1 billion some dollars and, 10 times the revenue multiple, but also very large and the kind of
yeah.
like exit that we haven't heard of for years and years and years in engineering software. And so the question is like, where are these all acquisitions all of a sudden coming from?
Yeah.
And I think it does tie back to AI and the need for a lot more chips and the whole ecosystem of engineering tools that are kind of in that space. They're just getting dragged along,
Mm.
swept along with this need to develop faster and keep up with the artificial intelligence that we're creating, apparently.
Yeah. And to get a little meta here, I've been thinking about it from, I think that world that we both live in, not the
Hmm.
super technical in the weeds of it, but a little bit higher up and just looking at what's happening more globally.
Hmm.
Um, I definitely I don't know I think about space infrastructure after talking to so many folks in the field and how
Hmm.
we really have no more infrastructure around the moon than we did 50 years ago. And so
Mm.
we have to build all of that. And then
Mm.
down here, we're still using the same internet that we had 10 years ago. The
Hmm.
infrastructure has not changed. Yeah, that we might have 5G from 4G and LTE, but what happens when all this AI starts building content on the internet? Are the pipes going to get filled up and
Oh,
clogged?
that's a great question.
Is there enough power to power is there enough resources for whatever it is that is being created for it to develop at the rate that it needs to develop? And I'm wondering if we're hitting a limit and rushing at this AI thing too soon, where we're just gonna clog up the pipes. It's a weird. I haven't gotten a good answer from it yet, but it's a weird question. And we were talking about sci-fi, and that just made me think about that.
Yeah, I mean, honestly, just technology scares me.
It's wild.
Yeah, I do feel growing up with a lot of science fiction, I do feel that science fiction doesn't have a tendency to come true.
Mm,
Not all of it, luckily, but it does.
yeah.
And so, um, it's a interesting times that we live in. I'm
Hmm.
definitely above my pay grade to talk about what AI is going to do to us all, but to say that it does feel like things are moving really fast, right? Doesn't
Mm,
it to you? I don't know.
absolutely.
To me, it just feels like everything's just moving
Hmm.
too fast, and
And
it's like,
each
where are
thing
we
is doing
rushing?
that.
Where are we trying to get to?
I know it's
Right.
true, and it seems like the deeper into the technology hole you go, like if you go Web3 and cryptocurrency stuff, that stuff is the most tech of it, and it's moving way faster than I can even keep up with it. I don't even know if the people writing about it can keep up with it as much as they can. It is I don't have any good answers. I just know that the principle that we're running on here is we don't ever want it to look like magic or to be, believed in as magic. Like it is a science. There is we can try and at least understand it at some level. And at least if we can talk about it and ask the question ahead of time, maybe we'll be okay. But if we don't, I think it might speed past us and become magic. So who knows?
Who knows? There's a really good book I read recently called Quantum Supremacy
Ooh, great name.
by a professor at NYC. I think he's originally from Japan. Um,
Mm,
and it's a really good book. I read it in like I don't know, an evening. And so he talks about different scenarios of what could happen with AI. And it's fascinating. It's
mm.
not if you like science fiction, but you're an engineer, that's a great book. I highly recommend.
Oh, cool. I'll have to check that out. Thank you. So the quantum supremacy?
Quantum Supremacy, yeah.
Very cool.
It's really good. Yeah, we'll see. We'll see what happens. One thing I do know though for sure is I don't know what's going to happen with AI and with all this technology and where we're trying to rush to.
Yeah.
I do know that the number of engineers is not increasing drastically, and I do know that
Mm.
engineers make this world a better place for the most part. Developers, no, I'm just kidding. I don't want to say that, but
Jokes,
engineers
jokes.
that are studying jokes, that's right. You're studying mechanical aerospace, electrical engineering. We tend to be very methodical,
Mm.
thoughtful, um risk averse people.
Yeah.
And you can blame engineers for going too slow, especially in larger companies and things like that.
Mm.
But at the same time, they also make sure that there is multiple safety factors in a bridge or in
Mm.
a car or in a plane. And the engineer's biggest fear is that to avoid any like large disaster or whatever, like the biggest goal in life is to avoid any large disaster. And
It's true.
so I do believe the world needs more engineers. And so
Mm.
any young people listening to us right now and contemplating on what to do, become an engineer. You could always do other things
Yeah.
like Alex and I are doing, but
Exactly. Yeah. There's always the opportunity to have another career change. But I will say I I definitely struggle with the engineering side of things. It's mainly personal stuff of just like that I've gotten over, but that's the angst that started this podcast was not being able to find that engineering job. And of course, now that I've found my niche here and I figured out really what I was looking for, um I have a huge respect for the engineers that are real classic engineers because we we like you said I flew on two planes the last week and I'm very glad that there were good engineers that built those planes and designed
that's right.
them and made those safety factors in play. I'm very happy about that. I definitely think I'm seeing this online. There's as I'm getting older, I'm watching the kind of the next generation of engineers coming out, and a lot of them who are now more online. I'm seeing a trend of a lot of burnout and a lot of career transitions out of engineering, and I'm wondering, is it less people getting into engineering as a field? Like, is there a large brush of people getting in college wise and then not completing? I'm definitely interested because I know it's a struggle. I mean, you've been there. It's not an easy degree or field to get into, but you learn a lot about the real world and how matter and things and how everything interacts with each other. Um, what kind of advice would you have for, as you see your teams that you're building, especially the generation that's coming up here? um what kind of advice do
Mm.
you have for folks for getting into engineering and into the field?
Yeah, I think you're right. I think there's a lot of burnout just everywhere. People just tired. Like COVID really hit the world hard, and
Yeah.
then ever since then, and I think just seeing the pace of things with AI, how just everything is just too fast, and
Yeah.
people are just exhausted, and engineering is hard, and doing hard things when you're exhausted, a lot of times there's not much reward on the other side
Yeah.
of things, right?
Yeah.
And so I think if people are burnt out, then you got to take care of yourself first. But
Hmm.
if you can persevere and still push through the hard thing, I can tell you that I've never regretted my engineering degree. And again, I'm not a typical engineer. Math is very hard for me. I had bad grades in math. Like that was one of my worst subjects until in high school, I decided that's it. I'm going to force myself to do well in math.
Yeah.
And I always had to work a lot harder than anybody else in my engineering classes. I was never straight A student. But I found ways to learn engineering in a way that's much more social, and
Mm.
it opened so many doors for me. Um, and I I would not give up my engineering PhD for anything. So I would encourage people to persevere and push through and know that if you do the hard thing that, you know, 99.9% of the world does not want to do, that it'll reward you on the other side.
Yeah.
One
Yeah.
way or the other. Even if you become a musician, an artist, a dancer, I don't know, a dog walker, a 3D, a podcaster,
Yep.
a YouTuber, TikToker, I don't know what people become nowadays. That engineering degree, it gives you a level of discipline that
Mm.
other degrees don't give you. And it gives you a
Yeah.
level of confidence, I think, that, and maybe you haven't, you mentioned, like it was hard trying to find a job, and sure that happens,
Mhm.
but I do feel like it gives you a level of confidence that you got a degree that most people are not able to get through.
Yeah,
Like,
and now that I have that job, I have such an appreciation for it. Um, to finally be here, to be that problem solver, that's in the mix every single day. And it's very Sherlock Holmes. It's very, I love the aspect of it. So I wouldn't
mm,
trade the journey of it for anything. And if anything, that journey is exactly what made me start a podcast. Um
exactly.
so if we can communicate here and do the more human side of things, we may have a job when the AI takes over. So then maybe.
Well, I don't think any of us are going to have any jobs.
No,
Let's
I'm
just
just
hope
kidding.
we're alive. I just don't want to be in the Matrix. Let me tell you, my biggest
Yeah,
fear
I'm
is I
with you
don't want
there.
that slime. Do you remember the slime he had to go through?
It's
Like when he was in
horrible.
that thing. I just don't want to go in that slime. That's all I'm
Yeah, that
asking. I'm
first
okay with
cough up
everything
of
else.
all the slimes, it looks like it's
Remember?
horrible.
And I always wonder, like, he couldn't breathe, right? Remember he came
Right.
out of it and he was like coughing, and that I don't want. Everything else I'll deal with.
Yeah. Well, what we hope for here always in the podcast is we used to say here's to a fantastic future, and I think now it's changed to here's to building a fantastic future for all of us.
Oh,
So,
I like that.
thank you. So Masha, thank you so much for coming on the podcast and talking about null space and your STEM origin story, and I think we got into some pretty great topics. Um,
Yeah, this was awesome. It was a
Thank you.
blast.
Yeah, absolutely. Any last thoughts to the folks out there as we close up the podcast?
Um, well, we've covered a lot of topics. Just, if you thinking about engineering, just do it. Do it, stick with it, get through it. The world needs more engineers.
You heard it here, folks. We've got the road to Artemis to build so that we can live in space. And I think if there's a problem hard enough for AI to solve, it's the final frontier. So let's all join that path together, AI and humans, and let's go tackle the final frontier because that's probably the only problem it's gonna not be able to solve quickly. So
That's right.
that's right. Spread love and spread science. Have a great week, and we'll see you on the next episode of Today in Space. See ya.
Thank you.